Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat bin Muhammad Nuri. I'm from DEM 2. My metric number is 01DEM 19F2010. So today I will talk about a transformer. First, introduction of transformer. Generator step up, GSU. Transformer represent the second largest capital in investment in reclamation power production, second only to generator. Reclamation has hundreds, perhaps thousands of transformers. In addition to hundreds of large GSU transformers, reclamation has transformers as small as a camera battery charger, about one half the size of a coffee cup, to huge generator step up transformer near the size of a small house. The total investment in transformer may well exceed generator investment. Transformers are extremely important to reclamation, and it is necessary to understand their basic function. A transformer has no internal moving parts, and it is transfers energy from one circuit to another by electromagnetic induction. External cooling may include heat exchanger, radiators, fans, and oil pump. Radiators and fans are evident in industry. The large horizontal tank at the top is a conservator. Transformers are typically used because a change in voltage is needed. Power transformers are defined as transformer rated 500 kV and larger. Larger transformers are oil-filled for insulation and cooling. A typical GSU transformer may contain several thousand gallons of oil. One must always be aware of the possibility of spill, leak, fires, and environmental risks this oil poses. Second, we will talk about principle of operation. Transformer function is based on the principle that electrical energy is transferred efficiently by magnetic induction from one circuit to another. When one winding of a transformer is energized from an alternating current AC, an alternating magnetic field is established in the transformer core. Alternating magnetic line of force called flux circulate through the core. With a second winding from the same core, a voltage is induced by the alternating flux lines. A circuit connected to the terminator of the second winding results in current flow. Each phase of a transformer is composed of two separate coil windings, one on a common core. The low voltage winding is placed nearest the core. The highest voltage winding is placed around both the low voltage winding and core. Internal construction of one phase. The core is typically made from very thin steel laminations, each coated with insulation. By insulating between the individual laminations, losses are reduced. The steel core provides a low resistance path for magnetic flux. Both high and low voltage windings are insulated from the core and from each other and leads. Transformer action. Transformer action depend upon magnetic line of force. That's mean flux. At the instant transformer primary is energized with AC. A flow of electron current begin. During the instant of switch closing, build up of current and magnetic field occur. As current begin the positive portion of the sine wave, line of magnetic force develop outward from the coil and continue to expand until the current is at its positive peak. The magnetic field is also at its positive peak. The current sine wave that begin to decrease cross zero and goes negative until it reach its negative peak. The magnetic flux switches direction and also reach its peak in the opposite direction, which end as the power circuit. The current change continually 60 times per second, which is standard in the United States. Other countries may use other frequencies. In Europe, 50 cycles per second in common. That's all from me. Thank you so much.